Hey everybody, this is your pre-calculus video on 6.4 having to do with graphs of sine and cosine. So just to begin with, when you're graphing it, you do document, new document, don't save, go to graph. And if you're going to graph sine or cosine or any trig function, you need to be in radian mode. If you're not, you can just click it. You know, there's degree, there's radian. There's also a way in a setting, if you are back to the home screen, you go to settings, which is number 5. Document settings is number 2. And that's another place where you can go to degree or radian. And we want radian. And then you just scroll down until OK. Okay. Again, if you were just starting right here, you can always press 1 for a new document and start over again. And you're going to do trig. The top ones are the ones we're going to be interested in. The bottom ones have to do with give me the angle for sine given these side lengths of a triangle, or give me the angle for sine given these decimals. But I'm not going to get into that too much, but that's what the bottom ones are about. Right now we're just on the top row. So we press sine x. You did it right if it's wavy between -1 and 1. And so then, like we've said in other videos, if you put a number in front of it, that's the amplitude. So now it's -5 to 5. So those are some things you're going to do. And the other one we're doing in this lesson is cosine. So it's COS. And again, anytime you're up here, make sure you put X. Don't try to put theta. Don't try to put any other letter because it won't work. So you have to use the X, which is this one. So I do cosine X, and that looks like that. Again, going from -1 to 1 by default. But we're going to do all sorts of transformations on it. Like we're going to have a negative sign here sometimes, which flips it up and down. We're going to do some things like have a number in front of here. Sometimes that number is going to have a pi, sometimes it won't. And that's actually going to relate to your period. So it's more wavy the higher the number it is. And so your period is shorter. So those are some things just at a high level, you know, that we're going to be doing. But the domain is all real numbers, and the range by default is -1 to 1. But whenever you put a number in front, you know, that's going to affect your amplitude, which affects your range. Your domain would stay -infinity to infinity, or like what we call all real numbers. Okay, so your first objective is to be able to graph when it's a sine omega x, that's a little fancy W, and for cosine. Now, in some books and in some online courses and things, instead of omega, they use B. Especially when they start talking about all 4 transformations when you do A, B, C, and D. So D is going to be vertical, C is going to be horizontal, and if I just make this real general, sine of x minus 3 means right 3. So sine x plus 1 means left 1. So the minus and plus are opposite of what you would normally think when it's inside the parentheses. But we've seen that before with every type of function, whether it's quadratic, cubic, rational, whatever, exponential. Anytime it's in parentheses, then it's the opposite. But this one, if I say sine of x, close parentheses, plus 3, means up 3. Sine of x minus 1 means down 1. And so that would affect your range. It would not affect your domain. I'll just say affects the range. Okay, there's a b variable that has to do with like the frequency. And it's related to the period. As we said, like in a different video, if I just do sine x, and if I change my window by going menu 4, if I change my window to the trig window, which is 8, I see 2 periods worth by default for sine and cosine. You could either say that side or that side. And if you cover up like the ends of it, a period goes from the top to the top, the bottom to the bottom, or the middle to the middle if you skip one. If you can visualize that, this would not be 1 period worth because it's only the uphill part, it's not the down. Or maybe I said that backwards, but it's only 1/2 of it. It's only above the x-axis. It's not the part below the x-axis. So this right there is not a period. That is. Okay, so that's what we're getting at. And you can also say from here to here is a period, and from here to here is a period. Period is a distance, and by default, it's 2 pi on everything except for tangent and cotangent, which is not going to be in this video. Okay, so your second objective is to be able to determine your amplitude and period. Amplitude is always easy because that's the number in front. Like I've talked about, it's A. The main thing is like your amplitude itself can never be negative. If there is a negative sign, that just means flip it, but you never say your amplitude is a negative number. Amplitude is never negative. If you had a minus sign, that would reflect. So flip it upside down. Your third objective is to find your equation based on some given characteristics or things like that. So while we're studying this, is the graphs are sometimes used in school spirit and in Christmas decorations, sometimes without y'all knowing it. Cheerleaders sometimes do this little thing that goes like that and then goes like that. Anyway, that's like a sine or a cosine graph. So anyway, also you might have word problems or application problems involving alternating current or AC circuits, AC generators, bridge clearance, and biorhythms. So since we want to graph it in the XY plane, we use X for the independent variable, which is also called the argument, it's the parameter, and Y for the dependent variable, which is the value at X. For example, f of X is sine X. Now, one of the most important things is you got to pay attention to your interval. Sometimes it's 0 to 2 pi, sometimes it's 0 to 2 pi, not including an endpoint. In this case, it's not including 2 pi. Now, the reason they do that sometimes is so you don't have to list everything that happens at 0 twice. Because 0 and 2 pi are technically the same thing. Because we've said before, like, if it loops around, 0 and 2 pi are the same thing. Just like 0 and 360 degrees are the same thing. So even though that's in the context of a circle, it's also in the context of whatever happened at 0 is happening at 2 pi on the graph. Like, it's an x-intercept here, it's also an x-intercept here, where on the left side it's increasing, you know. So just pay attention to things like that. Pay attention to your intervals and whether it's a parentheses or brackets. Brackets, again, mean include. Parentheses doesn't. Sometimes they change it to negative pi to pi, and sometimes they also want to show more than one period. Now, amplitude is your vertical height, and like I mentioned earlier, it's always positive, and the period is the horizontal distance for one complete cycle. So if the period is pi thirds, think it repeats every 360 degrees when it's normally every 360 degrees. So again, remember that since you have your pi at 180 degrees, that you can say 180 divided by 3 is 60. And again, you know, 60 was here, 60 more gives you 120, 180, 240, 300, and then back to 360. And then it just continues. And it continues there just like it continues, you know, horizontally left and right. Again, remember some basics. If you go to 4 and then to 1 for settings, if you wanted to make this negative 6 pi to 6 pi, that way you can. And so now you're seeing a lot more periods, even though the frequency didn't actually change, just your window changed. So notice that's still just sine x, but it looks more wavy. Now compare that to if I actually did sine of 6x, that looked super wavy, okay? And if I change that to be 2 pi, because sometimes you might have a pi there, sometimes you don't. Sine of 2 pi is also very wavy, because technically, like, pi is about 3.14, so 2 times pi is like 6. So 2 pi and 6 should look pretty similar. But again, sometimes you're going to have like pi over 6 or pi over 3 or whatever, and that makes it go a little bit slower. Okay, so the period does not show up explicitly. Like, you can say normally A is the amplitude, but the period is not in the formula. It is related to W, but it's not the W variable or the B variable in the other case. You usually use either capital T or capital P for the period. So you have this T equal the normal period divided by W, or P equal the normal period divided by B. NP is the normal period, which is 2 pi for sine, cosine, cosecant, and tangent. Cosecant and secant. The normal period is pi on tan and cotan. So for your properties of sine, refer to your notes. Again, I'll show you that. So if you have your unit circle packet, the back side was your trig identity chart. But what we're talking about now is related to graphs. And so this whole page is just on sine and cosine. So you're going to want to keep this handy. Everything in this lesson is about sine and cosine. Now probably the next lesson is all about tan, cotan, secant, and cosecant. So, and this part, which I'll talk about now, is not really on a lesson. It's just showing you, I mean, it's kind of related to this lesson. When you're going from 10 to 01, it's going up. So that value of x decreases because x is 1 here and x is 0 there. And so even though you're going up, the y value is up, but the x value is getting lower. And so that's why it's going from 1 down to 0. And then from pi halves to pi, you're going from 0, 1 to negative 1, 0. So it's going like this. Well, your x value is going from 0 to negative 1. That's what it says here, and it continues down. And then when you're going from pi to 3 pi halves, your x value is going from negative 1 to 0, which is actually going back up. And then you're going from 0 to 1, so it's going up even higher, you know, on the last part. So that's how the unit circle is actually related to the graph that we're doing. It has to do with your x coordinates for the cosine graph. So my takeaway from this would be that for the cosine graph, it starts at 1, or actually I should say starts at 0, 1, or goes through, I should say goes through or you could say starts at 0, 1, and then it goes. But sometimes it might go like this, where you're here and then it goes like this and then like here. So you can't technically say it started there, but it goes through 0, 1. So anyway, cosine, symmetric to the y-axis. Now on this one, we're talking about the sine graph, and so that's the y-coordinate. And so your y-coordinate goes from 0 to 1, which is higher, so then it's going up, and then it's going back down because it's going from 1 to 0, so that's what they have here, so it's going back down. Here it goes even lower, so it goes down 2 times in a row and then back up. So that's how that's related and why I included that page in the chapter. There's not really a question related to it, but it just connects your ideas. Okay, so again, going back to the properties of sine, the domain is all reals. Your range is -1 to 1 inclusive, which means brackets. It's odd because it's symmetric to the origin. So basically it goes through here and like that. And then you can just make it continue. You know, of course your calculator can do a better job graphing it than I can. You do have this, like, so many x-intercepts. Actually, the wording of one question was an infinite x-intercepts. Infinitely many x-intercepts. You only have one y-intercept and it's 0. The max is 1, and it happens at odd multiples. Well, certain odd multiples, and then the minimum is at other certain odd multiples. So you just have to see that, it's up there, which is at pi halves. Skip 1 at pi, and then here at 3 pi halves, it's actually a minimum. So that's where it goes from maximum at pi halves to minimum at 3 pi halves. And then it goes back to, if I do my intercepts, 0, pi, 2 pi. The next one would be 5 pi halves, because you're adding pi halves every time, and 2 pi halves. Sorry, 2 pi is like 4 pi halves. So when you just go a little bit over, it's back up, and that's why this goes back to 5. So basically, between here and here is your numerator increases by 4. Numerator increases by 4. And same thing here. Okay, pretty straightforward. You can read through the corresponding part on the cosine. Now the main difference is the y-intercept's 1, but again you have infinitely many x-intercepts, just they're at different spots. Now here's where they're saying, sine x is cosine shifted right, or you could say cosine is sine shifted left. So right is with the minus, left is with the plus. I think I showed this before, but I'll do it again. Repetition helps. If I just say my left side is f1, there's sine x, and here's going to be cosine x minus pi halves. Whoops. Pi halves. And so it flashed red and now it's purple. And so again, you can go to your table and compare the numbers and they're identical. I'm not going to repeat so many times the things, but these numbers really don't help. You'd have to change your scale to be like pi fourths or pi halves for it to actually make sense. Like change your step to be pi over 4, and then you can see it going 0 to 1. And again, God, I really am repeating myself a lot, but maybe this is the first time you've heard it. If you have e to a negative number, you may as well think of that as 0. So if I'm talking about my y values, it's going 0, skip 1, skip 0, skip -1, and repeat. And my left's, the function values are the same. Now, again, if we just change this to only have x here for cosine, then they're off a little bit. And I'm going to change my sign to be x plus pi halves. Then they're going to match. Now, somebody's going to say, well, what happened if you went minus? So, what happens? It makes a chain length. If you flip your sign, if change from minus to plus looks like a chain link. And on this one, plus to minus. So it's pretty decorative. Now, if your W is greater than 0, then you have this formula, like we said, where the period is the 2 pi over W. Amplitude is always positive because it's a distance. So when you're using 2 pi over W, notice that if W has pi, the The period won't, because say you have 2 pi over pi, then that cancels. So the period equal 2. But if w were just 3, like say you had sine 3x, then your period would be 2 pi thirds, which is a little bit random, but it's basically going to be 2 pi over that number. And then here, if you're doing sine of 3 pi, then you're going to do 2 pi divided by 3 pi, because 2 pi would always be in your numerator, and then your pi's cancel and you get 2/3. So there are a few questions like that that you'll see. So then your steps are determine your amplitude and period, divide your interval into 4 subintervals that are the same length. Pay attention to your middle line that defaults as the x-axis. Now what I mean by that is, what if you're here, but then it shifts up by a little bit, then your middle line would be like right there. So your amplitude is measured from the middle line to the max, or from the middle line to the minimum. Use your endpoints to get your 5 key points. Sometimes they're going to do things like the x-intercepts, the minimums, the maximums, and then you can draw it. Now it is optional to use your trig graph paper, and if you want to use map colors or colored pens. Trig graph paper looks like this. At the moment, I'm not going to use it because all your assignments are on Math Excel, but you know, that's something you can take notes on, or if you want to work some of your Math Excel problems on paper, you can, you know, just for notes. What's nice is they're not labeling what the scale is. So most times it's just going to be from -1 to 1, but maybe you want to change your scale to be by half, so then -1 to 1 would be like that. So you can change your scale. And I gave you 4 graphs. If you want more, we can get those. Okay. Now let's actually start the problems. I know sometimes y'all fast forward through that part, which is fine. But I'm going to go from here. Your maximum value of sine is 1, and it occurs at pi halves for your first one, if it's between 0 and 2 pi. Now, as y'all probably already know, it's repeated twice because it's like because it has your answer right there. That's why it's twice. I mean, it's like it has the question and then where you put your answer. So anyway, your maximum's at 1 and it happens at pi halves. If you have amplitude 3 and period 2, then your amplitude is 3, and then you'd have to do 2 pi divided by 2 to get pi. So that's that answer. Okay. If you want the whole formula, like we said before, period equal the normal period divided by W. So period equal 2 pi divided by W. In this case, they give you the period, so you'd say 2 equal 2 pi over 2 W, sorry. Then these have to switch places, so you multiply by W, you divide by 2, and then you get pi. So that's with the T and the W variable. We could have said with the P variable, NP over B, but it's the same thing, and here they're using W. So anyway, so you have T equal NP over W, or you could say W equal NP over T. So if you want to go ahead and, use those interchangeably, you can, depending on what they're looking for. Okay, now on this one, we have 7 cosine. So that means your amplitude is 7. It goes through 0, 7 because it's cosine. Now here they're telling you the interval to use. I'm going to do document, new document, and go to 7 cosine x. It doesn't make sense in this case to use the trig window because, let me just show you what would happen. I mean, I guess it's not bad, but you still have to think. Your trig window is not that helpful because you're going to 7. So you can change your window settings and change these. If you want it to be like pretty good window, I'd say -8 to 8, where you can change it right there. Or like, as I've told y'all before, if you want to double click the number and say -10 here and 10 here, oops. You can do that too. So you can double click on these. I don't think you can actually, well, can you just drag the graph over? Yeah. I mean, if you want to like see what's happening dynamically to all these values, you can. Like, hey, I'm moving it right, so it's, the numbers are affecting that way. If I'm moving it left, it's going this way. My numbers are getting smaller. So anyway, kind of interesting a little bit. And I just hit escape to drop it, by the way. Okay, so your y-intercept is at 7. On that interval, let me go back to the default. Get rid of any of these shifts. Okay, and then if I make this back to -pi to pi, and make this -10 to 10. That's the interval they're talking about. So it's decreasing from here to here. Now, remember whenever they're asking about decreasing or increasing, it relates to the x values, not the y values. Increasing, decreasing relates to x. Now, I mean, you see literally the y values falling, but your answer is related to the x. Your y value falls, but the answer relates to x since it's where it happens. Okay, then it says, what is the absolute minimum? It's the y value. And since it was 7 cosine, it's going to be -7, which is down there. And it says, for what values? Is it 7? Now they changed the interval on you. Okay, so that's why you got to watch out a little bit. So if we go to our window settings and change this back to -2 pi to 2 pi, then you can see it's actually 7 3 times. It's -7 2 times. So plus and minus 2 pi and 0. Now, they want a fancy notation for the x-intercepts. On that, I'd say just learn it. Usually at this point, just real quickly, 2k minus 1 over 2 is an odd number pattern. Oops, number pattern. 2 times 1 minus 1 over 2 would be 1/2. 2 times 2 minus 1 over 2 would be 3/2, and so forth. So it'd be multiples of a half. It's basically going right. See, the whole thing about the 2 there and then divide by 2 is I want it to be even. No, I don't. I mean, they do that on purpose. It's kind of weird. They want to cancel it out. I don't know. And then the minus meant go to the right. Go to the right 1/2. There's all kinds of number patterns, other number patterns they can use, like 4k, 6k, you know, whatever, 10k. That's the part to start it to be even. And then they can say plus or minus an odd number, like 1, 3, 5, whatever. So you can do any combination. You could say 6k plus 1, you could say 4k plus 5, and so forth. The main thing is it just changes your starting point. But this should be pretty obvious, and you can use your other notes, you know, which tells you it. Now we're doing 7 sines, so your amplitude 7. There was no number in front of x, and so it's 1, which means you have the default period. No number in front of x, and so it's the default period. A period is just a cycle, just like class period 1, class period 2, and so forth. So then on this one, you've got a 5, so we put a 5 for your amplitude. Your pi goes here, and then it's 2 pi over pi, so it cancels, and so you get 2. I could see the most common mistake on this one being that you put this amplitude as negative. The amplitude is not negative. I can also see y'all doing this homework assignment much quicker than I'm explaining it. This is 5/3, this is 5/3. Now you do need to do 2 pi divide by 5/3. And so one way to do that is to say 2 pi over 1 over 5/3. Multiply these and you get 6 pi, multiply these and you get 5. Or you could say 2 divide by parentheses 5/3 and then write pi in the numerator. Two divide by parentheses 5/3. So there's 6/5. And then you write 6 pi over 5. Okay, now we're doing a cosine graph, which, you know, by default, cosine goes through here. It's negative, so instead of going like that, it's going to actually be low at -4. So that's that one. Because that's 0, -4. And that's the property of it. Now, I don't see any others that were close, but just pay attention to your scale, because this has 2 pi labeled, and then the one before it would be pi. They don't label every single one, so just be careful to your scale factor. You can always graph that. -4 cosine 1/4 x. And so that's that. But I need to change my window to be, whoops, my window. You, by the way, remember Control T to toggle between your table. But you want your window setting to be from -2 pi, which is about 6, to 8 pi. That's a good number, 8 pi. Okay, so that's how you can see that it matches. Okay. Now we have another one, and this tells me it starts at 0, 2. It goes like that. And it's going to be this one. This one goes through 0, 3. And so that's that one. Now, there are 2 like that. And so I do remember this last time I taught it. This one says 2 pi, this one says 8 pi, but the graphs look identical. Graphs look identical. So look at your x max. Because remember, if we did period equal normal period over w, your period would be 2 pi over 1/2, which is really 4 pi. And so, like, from 0 to 4 pi, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. 4 pi is right there. Whereas on this one, pi would be in the middle, and then this is pi halves, 3 pi halves. So, anyway, there you go. This one, you'd say period is 2 pi over 2, so that period is just pi. So, it's sine, so it doesn't start high, it starts at the origin. And it's positive, not negative, for my number. Of course, your numbers could change, like we've said before. So you can graph it and use your properties. On this one, they're going to give you a function, and your domain should be -infinity to infinity, and your range should always be from negative, that number, to positive. And then you just have to graph it. So I know the graphing part would probably be the hardest part to do, but remember to type pi to insert pi. They want you to show 2 cycles. So that part you're going to have to do on the calculator. You've got 5 here, you've got -5 here. This is where you really can start saying, well, I need to know my 5 points. So make sure it goes through 0, 0. Make sure it goes through pi 0. Then 2 pi 0. And then this would be 2 pi comma 5. This would be -2, negative pi over 2 and -5. And I think you can type your coordinates to help you. So anyway, just work through that. And then on this one, you have to graph it as well. And you're going from -infinity to infinity and -6 to 6. Make sure on these that you use your brackets. For your range. And then you might have to do your default values, like, trying to remember. It's probably going to have the default would be A is 1. Let me write the whole qualified thing. A, W, X, minus, well, let me do B. Bx minus C plus D. Your defaults would be A is 1, B is 1, C is 0, and D is 0. But if you actually have some number changes, like this default would be, well, I mean, the default would be 1 for A, but because it's a 5, you'd have to put A for 5. A equal 5 here, since it's 5 sine. But your B would still have to be 1. And remember we said B and W are the same thing. I don't know in Math Excel whether they use B or W for that part. I'm thinking there's a little pop-up box, so you can look at that. But your horizontal and vertical shifts by default should be 0. And there might also be a box checked for reflect the x-axis. Because of that negative sign in front. So instead of being at +6, it's going to be at negative. Okay, on this one, we want sine of 2x, and so you do your W is given to be 2, so your period would be 2 pi over 2, which is pi. So that's why they're showing negative pi to pi. And again, use your bracket, it's still going -1 to 1. On this one, you have more variables and more numbers. So again, the A is that, the W is pi, and your D is 2. That's your vertical shift. And you could say period is 2 pi over pi, so that's 2. So this time on your graph, instead of saying 2 pi, 4 pi, 6 pi, these numbers on the x-axis don't have pi. No pi for you. But these numbers on the x-axis have pi. So we can share pi there. So again, I know I mentioned this before, but I'm glad I'm going over it again. If this part for W is just a number, then your period part and your scale is going to have pi. W had no pi. But on this one, W has pi. And so your period part and your scale factor part does not. Now, because this did go through, or go up to by default, you could visualize it like with a horizontal line, and you could say 7 minus 2 equal 5. And then you could say 2 minus 5 is negative 3. And that's how you get the negative 3 to 7. You basically want to start at your 2. You're too high. Haha. And then you go up 5 from there, down 5 from there. That tells you your range. And this is where the graph itself may be a little tricky, but just use your variables and use your defaults. On this one, you'd have to check reflect the x-axis, and you'd have A is 5, D is negative 1. Since W is pi thirds, that means your period would be 2 pi over pi thirds, so that's 2/3. So that's where it is going to be a little tricky. So make sure you use good points. You might have to type in values for your points. Like, since this was negative 5 and then minus 1, you start with your negative 1. And by the way, they made it a little more complicated by not counting by ones, they're counting by half. You know, half, 1, 1.5, 2. And same thing for the negatives. And so then from that point, it's down 5. And again, from there, it's up 5. And so you got to pick your ordered pairs carefully. And so you would say negative 1 plus 5 is 4. Negative 1 minus 5 is negative 6. So that's how you get your numbers. Now you're back to just picking an equation, and whatever your number is has to be in front so you can eliminate choices real easily. And then if your period is 8 pi, period equal normal period divided by W. If you want to start filling in your values, you can. And then have these switch places. And so that's 1/4. Or if you want to start by saying W is normal period over T, then W is 2 pi over 8 pi. And so then you get 1/4. So then the question is, does the 1/4 make it repeat more, or does it make it longer or stretch out more? So 5 sine 1/4 x. That makes it like that, whereas if all I had was 4, it'd be more wavy. So I'm just going to label it that way, with 4 being more wavy and this being less wavy. Okay, because you have a large period. So it's going to be less wavy. So, like if you relate it to being on the coast, you're pretty far away from where the boats were. Okay, then for this one, they want you to write the sine function with those characteristics. The main thing is you wouldn't put 8 sine 1x. That's wrong because that's w and this is t. So you'd say w equal normal period over 2 pi. Whoops, I did that wrong. W equal normal period over the period. So that'd be 2 pi divided by 1, which is 2 pi. And so if the period was 1, then your W part would be 2 pi. And again, your number goes in front. I mean, some of these are going to be obvious based on your amplitude. I mean, so you have a 50-50 shot. And if this is 1, it can't be 1. Because period and W are not the same. W is not the period. W is not the period. Okay. Then you have this one. This one's a little interesting because you know you have to start with your amplitude part. And you do see it symmetric to the x-axis. And it's up 3 and down 3. And so that tells you it's going to be 3. Because it's actually on the y-axis at positive 3, then it's a positive 3 cosine. And then you got to figure out about your w variable. So if you want to look from the middle point, this max to this max, just count and I get 3. So that means my period is 3. And so for W, it'd be the normal period divided by the period, so 2 pi over 3. And that's what we have here. So either use max to max, which is what I usually do, or use min to min, or middle to middle. But that's a little hard in this case because those numbers are not exact. So use whatever's best for you. Now this one, it might help on your paper if you darken the y-axis. Just notice it's right there because you have a little bit in front and a lot in the back. So this has to be a cosine graph at 4/5. So that means it's 4/5 cosine. That's your first thought process. And so there you can rule out all those choices. Is it 4/5 sine or is it 4/5 cosine? And I mean, you can see it's 4/5 cosine. The other part I didn't even have to do. But if I did it just for grins, this period is a half. So W would have to be the normal period over the t. So W is 2 pi over 1/2. And that turns into 4 pi. Because it's 2 pi over 1 over 1/2. And multiply those and multiply those. The extremes and the means. Okay, and then for the last one, this one does have a shift. What you can do is kind of like visualize if you're going from -16 to 0, that meant my middle line had to be 0 minus 16 over 2, which is just -8. And so then you can see it could be this one or any of these three basically. And we know that it was going to be a cosine graph because it's actually on the y-axis where it's high. So we know at this point it's cosine and it's a -8. And we also know this is 8. Now the part we don't know is this part, for the W. So again, you go W equal the normal period over T, which is 2 pi over, okay, now you gotta do it by counting, or just looking here to here is 1/3. So 2 pi over 1/3, that's like 2 pi over 1 over 1/3, and so that's 6 pi. So that's how you get that. Okay, nothing on this side. Hope that helps. Have a good day.